We all hear about sports concussions, right? But how do they really happen, like on the field? Well, today we're going to skip the headlines and dive right into the science. We're unpacking a massive 10-year study that followed college athletes to figure out exactly where, how, and why these injuries are happening. Okay, so I've got a question for you. Just picture it. That huge, game-changing hit in football, hockey, or soccer. The one that causes a concussion. Where does that impact happen? Is it the front of the head, the back, maybe the top? Go ahead, get an answer in your head, because what the data shows, well, it might just surprise you. So here's our game plan for this explainer. First, we'll get into the study itself. Then, we're going to pinpoint the head's most vulnerable spot and see what specific dangers are unique to each sport. After that, we'll look at a pretty surprising difference between male and female athletes, and then dig into the scary, compounding danger of getting hurt again and again. And finally, we'll ask the big question: what do we do with all this information? All right, first up, a decade of hits. We're looking inside the McGill University Concussion Study. This is where all our data is coming from, a huge 10-year study from McGill University. So you know the foundation for all this is rock solid. And get this wasn't just them looking back at old records or sending out surveys. No way. For 10 straight years, researchers were tracking these college athletes in real time. That's what's called a prospective study, and it's basically the gold standard. It means we get super high-quality, reliable data about what was actually happening out there. Over that whole decade, they recorded 226 concussions in 170 athletes. And listen, 226 isn't just a number. It's a huge data set. It's big enough that we can start to see real, undeniable patterns. A bit of clarity in the chaos of these high-impact sports. Okay, so now we get to our first big reveal. Let's answer that question I asked you at the start. The most vulnerable spot. And yeah, this one challenges a common assumption. So did you guess it? The answer is the side of the head. An incredible 43% of concussions came from hits to the side, the temporal region. I mean, think about that. That's almost 3 times more common than those big, dramatic, front-on hits you see on all the highlight reels. But why? Why is the side so much more vulnerable? Well, as the lead researcher put it, it's pretty simple. It's the hit you just don't see coming. You can't prepare for it. But there's more to it, a deeper, more scientific reason. It's all about something called shear stress. See, biomechanical models show that side impacts create way more of it. Just imagine your brain is kind of like Jell-O. A hit from the front just compresses it, right? But a hit from the side, that makes it twist and stretch, causing different layers to slide against each other. And that sliding motion is way, way more damaging to all those delicate connections in your brain. All right, next section, sport-specific dangers. Because not all hits are created equal. We know where the hits are landing now, but things get even more interesting when we ask what's doing the hitting. And as you're about to see, the answer is totally different depending on which sport you're playing. And here's where it gets really distinct. For football and soccer, it's pretty straightforward. Most concussions are caused by hitting another player's head or helmet. Simple enough. But in ice hockey, head-to-head contact is actually way less of a factor. For them, the danger is coming from other body parts, and this is key, from the environment itself, like the boards or the ice. Let's zoom in on that hockey data for a sec. The number one cause? The boards. Over a quarter of all concussions in hockey came from hitting the boards. Right behind that is hitting another player's shoulder. You know what's not on that list? Another player's helmet. It's not even in the top 4. That's a huge difference from football. And then there's soccer. This number is, wow, 50%. Half of the concussions in soccer where they had the data were related to someone trying to head the ball. But here's the really important part. It's usually not the ball that does the damage. It's the head-to-head smash-ups that happen when 2 or more players go up for that same ball at the exact same time. Okay, moving on to a gender difference, because it turns out it's the same sport, but different risks. The study didn't just stop at comparing sports. It dug deeper and found this really fascinating and super important wrinkle in the data. Even when they're playing the exact same sport, male and female athletes were facing different kinds of risks. The details here are really telling. So in ice hockey, female athletes were more likely to get a concussion from hitting the boards. For male athletes, though, it was more likely to be an elbow that caused it. And in soccer, while head-to-head was the biggest cause for everyone, female athletes were way more likely to suffer a concussion from the ball itself. So what gives? Why the difference? Well, the study suggests it comes down to biomechanics. Things like, on average, female athletes having lower neck strength and mass. So what does that mean? It means that when an impact happens, their head and neck might just accelerate more. and that could make them more vulnerable to forces that a male athlete might be able to shake off. And that brings us to our next section, the danger of repetition and the compounding effect of injury. Now, this is probably the most serious finding in the whole study. It's not about just one injury. It's about what happens when those injuries start piling up. Okay, so let's set a baseline. The study looked at a group of athletes who got at least 3 concussions. For their very first one, the median recovery time was 12 days. Got it? 12 days. Keep that number in your head. Now watch this. After their second concussion, that same group of athletes, they needed 17 days to recover. 17. That's a huge jump. It's a 42% increase in how long it took them to get better. The brain is pretty clearly telling us it needs more time to heal the second time around. And for their third concussion, the number jumps again, all the way to 21.5 days. The pattern here is impossible to ignore, and honestly, it's pretty scary. With every single injury, the brain takes longer and longer to get back to normal. It's a crystal clear cumulative effect. So let's talk about rethinking player safety. What does all this investigation mean for the future? After going through all this data, what's the big takeaway? How can everything we've just learned help us make things safer? Okay, let's wrap up with the key takeaways. First, the side of the head is the #1 most vulnerable spot. Second, where the hit comes from changes a ton depending on the sport. Think head-on-head versus hitting the boards. Third, there are real gender-specific risk factors. And finally, and this is the big one, recovery time gets longer with every single concussion you get. They stack up. So all of this leads us to one final, really important question. We have the data now, we know the what, the where, and the how. We know the most vulnerable spot, we know the most dangerous plays, and we know for sure that the risk gets worse over time. So the challenge isn't about not knowing anymore, it's about what we're going to do about it. Are we, and I mean everyone, coaches, leagues, fans, are we willing to change the games we love to better protect the next generation of athletes? That's the question this research really leaves us with.